Have you ever wanted to learn to code but just felt totally lost? Like you don't even know where to begin? Well, if that's you, you're in the right place. We're going to cut through all that noise and lay out a clear, simple roadmap to get you started on your very first line of code. Let's build that roadmap together. Right? This is the big one. It feels like you're standing at the bottom of a huge mountain, and there are like a dozen different signs pointing up, all saying, this is the best way. The sheer number of programming languages, tools, and opinions out there can be absolutely paralyzing. And look, if you feel that way, you are so not alone. This comment from a Reddit user just nails it, doesn't it? It perfectly captures that feeling of frustration and then that huge wave of relief when you finally find a clear path. That's a feeling a ton of people share. So let's just get this out of the way. It's totally okay to be overwhelmed at the start. I mean, you hear about Python and JavaScript and C++ and web development and data science, and everybody has an opinion about which one you have to learn first. It's no wonder so many people get stuck in what's called analysis paralysis and just never even start. Okay, so here's the secret. The real first step, before you even type a single character of code, is learning how to think like a programmer. Seriously. It's not about memorizing commands, it's about developing a problem-solving mindset, and it has a name, computational thinking. And don't let the name fool you. This isn't some high-level academic concept. Computational thinking is the honest-to-goodness toolkit that professional developers use every single day. It's how they take a really complex problem and turn it into software that actually works. This is the foundation for everything else. The very first tool in that kit is something called decomposition. It sounds a little fancy, but the idea is incredibly simple. It's just the art of looking at a big, scary problem and breaking it down into a bunch of smaller, much more manageable pieces. Think about baking a cake. You'd never just say, okay, time to make a cake, and magically a cake appears, right? No, you follow a recipe. You gather the ingredients, you mix the dry ones, you mix the wet ones, you combine them, you bake it. You're following a set of decomposed steps. Programming is exactly the same thing. All right, the next key skill is abstraction. This one is all about managing complexity by, well, hiding it. It means you focus on what something does without getting bogged down in the nitty-gritty details of how it does it. And trust me, you use this concept all the time. For real, think about ordering fast food. You don't walk up to the counter and say, okay, please go grab a bun, then walk over to the grill, get a cooked patty, add lettuce. Of course not. You just say, I'll have a number 3. That number 3 is an abstraction. It's a simple command that represents a whole bunch of complex steps. Programmers build these kinds of shortcuts all the time to keep their work sane and manageable. Okay, so we've got the mindset down. Now let's see how that thinking actually translates into real, actual code. This is where we go from theory to practice, and I promise it's way more straightforward than you probably think. One of the very first things you're going to meet in coding is a variable. Now, a lot of tutorials describe it as a box you put information inside. I want you to think about it a little differently. It's more like a label or a name tag that you stick onto a piece of information. The variable doesn't hold the data, it just points to where you can find it. It's a subtle but really important difference. And here you can see that idea in action. The program asks for a name, the user types in Larry, and the code sticks a label called name onto that word. Then, a moment later, it uses that name label to find Larry and print the friendly greeting. It's simple, it's powerful, and it is a fundamental building block for pretty much all programming. But here's where you gotta be careful, because computers do exactly what you tell them to do. If you tell a computer to add the text 2000 and the text 18,000, it's just going to smush them together into one long piece of text. It doesn't know you mean math. This is such a classic beginner mistake, and it highlights a key lesson. You have to be specific and tell the computer whether you're working with numbers for calculation or just plain old text. So once you start writing more than just a couple of lines of code, you're going to run into a new problem pretty fast. How do you keep track of all your changes? How do you go back if you mess something up? And how do you eventually work on a project with other people? Well, that's where a professional tool called version control comes into play. The tool that basically everyone in the industry uses is called Git. And don't let the weird name throw you. At its heart, Git is just a super-powered save button. It lets you take snapshots of your entire project at any point in time, creating a complete history. This system is so powerful, it's what lets thousands of developers all over the world work on massive, complex projects together. The basic flow goes something like this. You make your changes in your working directory. That's just the folder on your computer. When you have a change you like, you move it to the staging area, which is kind of like putting a file in a box to get it ready to be saved. When you commit, you're sealing that box and saving it to your local repository. That's your own personal history of the project. Finally, you push those changes up to the remote repository so everyone else on the team can see them. But honestly, the real magic of Git is a feature called branching. Think of your main project as a stable tree trunk. It's the single source of truth. When you want to try out a new idea, you create a new branch that grows off that trunk. You can do whatever you want on that branch, experiment, break things, fix them, and it has absolutely zero effect on the stable main trunk. It's a total game changer for working safely and collaboratively. All right, we've talked about the mindset, we've talked about the tools. But what's the best way to actually learn all this stuff and make it stick? The answer, my friend, is simple. You've got to build things. And this right here shows why. Look at the difference. Traditional learning is passive, right? Someone lectures, you memorize stuff for a test. But project-based learning completely flips that around. It's active. It's driven by you trying to solve a real problem and build something real as a result. And it just plain works better. You're way more motivated when you're building something you care about. You get instant feedback. I mean, your code either works or it doesn't. There's no ambiguity. This whole cycle of trying, failing, and figuring it out just helps you master skills so much faster and remember them for way longer. In the end, it really all boils down to this fantastic piece of advice from one learner to another. Stop worrying about picking the perfect language. Just pick one and start making stuff. Anything. A little game, a simple calculator, anything. That is how you will actually learn. And that brings us right back to the beginning. Remember that feeling of being completely overwhelmed and alone? Well, the journey into coding doesn't have to be a lonely one. In fact, it's an amazing chance to connect with people. And here's the final piece of the puzzle. All those places online, like the Reddit thread we saw earlier, the places that seem so full of confusing, conflicting advice at first, they're actually your single greatest resource. That's where you'll find people who've been where you are. It's where you'll get support, find answers, and maybe even find people to build things with. So you started out with the question, where do I even begin? But now you have the roadmap. You know the mindset, you know the basic tools, and you know the best way to learn. So the question isn't, where do I start anymore? The real question is, what are you going to build?